Hello, students, and welcome to today's lecture where we are going to go ahead and go over redox reactions. And in this section, we're going to be doing a little bit of balancing with redox reactions. We're going to get to see some redox reactions. And there are many things in this section that we're going to want to take note of. But the first thing that we're going to have to do is talk about what they are in general, and we're going to have to go ahead and label what this redox means, okay? And this is one of those things that, if you've had brothers or sisters or family members, they may have had horrors of balancing redox reactions. But it's actually not as bad as they think. It's just like you just have like a process that you have to do, and it's, just one step at a time. Okay? But we're first going to go ahead and define it. Redox reactions are oxidation reduction reactions, okay? And it basically just means that there's going to be some sort of transfer of electrons going on, okay? Oxidation is oxidation is something that happens to elements in a reaction, and it involves the loss of electrons. Whereas reduction is going to be the gain of electrons. Yeah. So if something is oxidized, that means that it loses electrons. And if something is reduced, that means that it gains electrons, okay? Both half reactions are going to happen at the same time. So that means that when you have an oxidation, you're also going to have a reduction at the same time. And the last thing is that usually any combustion process is also going to be classified as an oxidation, as it is going to involve a gain of oxygen. But realistically, it's more that, the oxidation of most of the carbons is going to end up changing there. Okay. So, in general, what we do for this is that there's going to be a couple of terms. So those of you that are non-language people are going to, you're probably going to end up struggling with this just a little bit here. And the reason is because there's some language that goes with it. In particular, substances which help oxidation occur are called oxidizing agents. Okay? And these are substances that help oxidation to occur. They're the ones that are essentially taking the electrons. And then reducing agents are the ones that are usually pretty good about giving electrons there. Okay. Here is an example of a redox reaction. And what we have done here is we have two things happening here. First, we have carbon dioxide and hydrogen coming together. And what I have here is we have what's known as the oxidation state for both of these compounds here, okay? For this carbon, it is right now at an oxidation state of +4. And the reason it's at an oxidation state of +4 is because it has these oxygens, and those oxygens are kind of taking its electrons, so to speak. And then as it does this reaction, and it reacts with the hydrogen, it ends up losing one of the oxygens, which means that it ends up getting reduced, okay? One easy way for me to go ahead and, visualize this myself is that this one is getting reduced. Its number is actually going down. Its number is being reduced, so it's going from a +4 state to a +2 state. The hydrogen here, it has two hydrogens that are sharing their electrons evenly. When something shares its electrons evenly, we typically say that it has an oxidation state of 0, okay? And then when they come over here, they're going to lose a little bit of their oxidation state. They're going to lose essentially their electrons when they bind up with the oxygen. And when they lose their electrons, that means that they have been oxidized by the oxygen. And that's also why it ends up being called, well, that's also why oxygen is called oxygen. We knew about this oxidation process before we knew that oxygen existed because, oxygen just happened to be a very good oxidizing agent. It was really good at causing oxidation to happen. This is also something that happens with iron. So iron, if you get iron wet, what happens is that you give a method for oxygen to go ahead and react with the iron to make iron oxide. And that right there is an example of an oxidation reduction reaction. So we can go ahead and go over that one. So, oh my, look at that. We normally have iron, and iron, when it is by itself, has all of its electrons, okay? And then what happens is that when we add oxygen to it, that oxygen is going to take, it's going to take it. So it's going to take some of those electrons. And in this case, we can see that it's going to end up taking a lot of the electrons. It's going to take 3 electrons away from each iron, okay? And this is an example where iron ends up getting oxidized because it loses electrons, and oxygen, which technically has a 0 charge right here, ends up getting reduced because it ends up taking those electrons, okay? And then here we were supposed to have questions, but now we also have tests for these oxidizing and reducing agents here. For the test for an oxidizing agent, that's going to be potassium iodide. And what happens with potassium iodide when it's in solution is that it goes from colorless to brown, and it basically indicates, hey, there is an oxidizer here. All right. So potassium iodine, in and of itself, when it's in solution, it ends up being in a clear solution. And when you oxidize the iodine, what happens is that you can go ahead and have it bind with a starch complex, and that'll end up turning it brown. Whereas with potassium dichromate, for our reducing agent, what happens is that we actually reduce down the chromate even further. I believe we make the chromate go from a +2 oxidation state to a +3. So here we go. This is the example here. Here, this is potassium iodide. And a brief reminder that potassium iodide is a salt. So that means that the potassium is +1 and the iodine is -1. When it reaches and connects up with an oxidizing agent, what will happen is that the potassium +1 will still be in there, but the iodine ends up forming I2, okay? And that I2 is, has a charge of 0. Each of these iodines has a charge of 0, which means that we went from a -1 state to a 0 state, which means that this iodine in particular had been oxidized. Whereas the oxidizing agent, the thing that had stolen the electrons, that steals the electrons, has now been reduced because now it has stolen those electrons. Okay? And the same thing goes for here. In this case, what's going on is that the chromate right here ends up being oxidized and then we end up making, other things like water right over here. Let's see, 7. No. No, sorry, the chromate ends up being reduced because we'll get into that here. But basically, these are the two tests that we're going to be using to basically go through them here. When we go through tomorrow, we'll go ahead and go how to and indicate how to figure out the oxidation state for these different elements. What I'll go ahead and do right now is go ahead and give you a preview for this one, because if I don't do that right now, it'll bother me for a while. So Cr2O7 has 2 chromiums and 7 oxygens, and it has a -2 charge. Okay. Each oxygen is going to take 7. There's 7 oxygens. And each one takes 2. We have 2 extra electrons, which means that the oxygens need to take a total of 12 electrons from the chromium. So this chromium right here, each one has a charge of +6. Okay? If chromium's reduced, it should have a lower charge on this other end here. And in this case, you do see that it does have a lower charge here. So this chromium here goes from 6 to 3, which means that it has been reduced. Okay? Whereas the hydrogens here, right now they have this one just shows that it's been reduced. Then these hydrogens, what happens is that they're going to bond up with the extra oxygens once the oxygens have been kicked off of the chromate here. Okay. That's going to essentially close us out for this section. This section, there's just a really quick things that I want you to recognize here. And that's the basic idea that substances that are oxidized lose electrons, substances that are reduced gain electrons. Oxidizers are the things that take electrons. Reducers give electrons. Oxidation reduction reactions happen concurrently. You're always going to have a reduction with an oxidation. Okay. And then the 2 tests that we have for testing to see if there are oxidizing agents or reducing agents are going to be to either add potassium iodine solution with a little bit of starch. Okay. Usually we add a little bit of starch to see it clearly. And then for reducing agents, we're going to essentially add potassium dichromate, and we like to add that with just a little bit of acid to it. So it has to be just like a slightly acidic solution of potassium dichromate. And that one there, in and of itself, is going to end up turning, from orange to green. So here is the potassium dichromate, and then this one here is the color for the chromate when it's in solution. Okay, so that's just a reminder of how those different compounds interact, and that should also go back with our transition metals, that when they have different transition states, different oxidation states, they end up having different colors. Okay, this is going to go ahead and close us out for now, and it should be a fairly easy set of work for you for today, because it's just a simple definition day, right? I hope this meets you well, and remember, stay lazy.